Kimmer here, and we're going to talk about input, process, and output using C. Using this, we will create a program and learn a little about your first C programming. But before we do, the very first thing I'd like to do is to talk about the steps for creating a program. So the first thing I need to do is determine the outputs. Now what that means is basically, what the heck is my program supposed to do? And once you figure out what the outputs are, meaning what your program is supposed to do, then the next step would be to determine the inputs that you need. What are the things that you need to know in order to produce the outputs? The third thing you need to do is create an algorithm. An algorithm is just a fancy word for step-by-step instructions. Order usually does matter in this case. The fourth thing you need to do is to code the program. This is where you actually get to write the code for the program. The next step after you get to code the program is to test or debug the program. And this is where you make sure you give it good test data, if there's any syntax errors or logic errors, which we'll learn more about. You'll see those shortly, I promise. But this would be the next step. The last step then would be to document the program. And so we're going to try to teach you good techniques so that you don't have to do as much documentation, because it's probably the least favorite thing to do. Please don't try to start at number 4 automatically. At least do steps 1, 2, and 3. If nothing else in your head, try to figure out, okay, what is my program supposed to do? What are the inputs that I need to get in order to be able to produce the output? And then what are the steps I need to follow, or what is the algorithm that I need? So if we go ahead and start our first program, I know you've already done your first intro hello world, so this will go just beyond that, but we're going to take it step by step and a little bit slower. So it'll be probably the longest time for the shortest program that you've ever written, but that's okay. So the first thing I want to do is to talk about comments. So we have our program here, and we have 2 forward slashes that we can use, and this is known as a line comment. So how that works is anything on that line after the 2 forward slashes will be ignored by the compiler. So you can go ahead and use this for notes. The other kind of comment that you might see is a /*. This is known as a block comment. Now a block comment allows you to create multiple lines of notes. Typically what you want to do is you want to make sure that you at least include your name and perhaps some sort of a brief description of what the program does. So we're going to do a quick little age calculation. And then don't forget to close the block comment. Notice it's the opposite, so it's an asterisk followed by a slash. Next thing we're going to do is to go ahead and add the pound sign, the hashtag, the number sign, whatever you want to call it. And we did this before, but this is called a preprocessor directive. Now all that really means is when you go through the compiling process, it'll go ahead and include whatever file that you decide to put here. We talked about the standard input-output, so stdio.h. H stands for a header file. So the information that you need for any kind of standard input-output, which in our case is we're talking about input and output, is going to be included here. The next thing you need to include is your int main. Now you'll notice I have open close curly braces and a return 0. The main is a reserved word. So in other words, you have to include a main if you want your program to run. It's considered the main or the driver function. So any of the code that we're going to be doing today is going to be in between the main and the return 0. So currently what you see on your screen with your comments, your include statements, and your int main with your return 0. This is the main structure for all the programs. Okay, maybe not all the programs you're ever going to write, but a lot of the programs that you're going to write. So you're going to want to start with this every time you go ahead and start a program. So since we're doing an age calculation, we're going to create some variables. So you'll see me do this with this. We're going to say int birth year, semicolon. So let's stop here. We have a couple of things. We have this int, which stands for integer, and we'll talk about that in a minute, but we also have a variable name called birth year. So let's talk about declaring variables. When we declare variables, there are certain rules that we have to follow for naming those variables. Okay, so let's go through the rules for naming variables. First things first, no spaces. Notice I put that in all caps with 2 exclamation points. I'm yelling at you. Yes, no spaces. This is one of the most common mistakes that new students make, is they try to put a space into their variable names. If you do, you're going to get errors. So it violates the rules for naming variables. So do not use spaces, please. Next thing is no reserved or keywords. For example, we couldn't use the word main because I talked about that being a reserved word. We can't use the word return. Okay. As long as you use words that make sense to you as to what they're going to hold, you shouldn't have any trouble. Next, do not begin with a digit. If you begin with a number or a digit, 0 through 9, then you're going to get a syntax error. So it can contain digits, but it just can't start with one. And the last rule is no special characters. So special characters like the $sign, the hashtag, the ampersand. The only characters that you're allowed to have are underscores. So you'll notice I put an underscore in the word underscore, and I know for those of you that are about to tell me that there is no underscore in the word underscore, I know that. I'm just telling you in case you forget what an underscore is. I'm showing it to you. It can be letters, uppercase or lowercase, and it can be digits 0 through 9. So now let's talk about the guidelines. Guidelines for naming your variables. First guideline is do not use all caps. Now, we'll talk about the difference between a guideline and a rule. If you break a rule, your computer will not allow you to compile your program. However, if you break a guideline, the compiler doesn't care. However, most people do. We create these guidelines for a reason. Your place of business or where you work might have some additional guidelines that you might follow, so I'm just going to give you the ones that I particularly like to use when you're first learning. So do not use all caps. That is going to be reserved for something else. The next guideline, do not begin with an underscore. That's typically reserved for something else as well. The third, do not begin with a capital letter. It can contain capitals, but don't start with one. Again, reserved for something else we'll use later. And the last one is be meaningful. We want to make sure, well, it's not quite the last one, but we want to make sure that they mean something. So don't use X, Y, Z, P, Q, R. Don't use just single letters for variables that are supposed to represent something else. There will be times where we might use an X, and we'll talk about when that's going to be okay to do. But in the meantime, if a variable is supposed to hold something like a person's age, then let's call it age. Then the next thing is to be consistent. Now there's lots of different ways to create variables or declare variables. So let me show you what a couple of those ways are. If you look at the program that we just did, notice I created birth year. So now I didn't use all caps. I didn't begin with an underscore. I didn't begin with a capital. And it's meaningful. You see what it's going to hold. However, you'll do notice that I do have a capital Y in the middle of it. This is known as camel casing. So every successive, you start with a lowercase, but every successive word begins with an uppercase. This is typically what I use. However, I could have declared that variable as birth year, like so. Okay. However, it's in all lowercase. It runs all together. Some people prefer that. I'm okay with it. You could also, for those people that like spaces or are used to Python, maybe want to throw in the underscore. Whichever way you prefer is fine. All I want you to do is be consistent. Okay? Be consistent with what you do. Typically, I'm going to choose camel casing. So let's continue. The next thing that you see on the screen in front of birth year is int. And I had mentioned that that stands for integer. So let's talk about integer variables now. There's a data type. We're going to talk about more data types, but not right now. For right now, let's just talk about the integer data type because it's the easiest one to work with. You already know what an integer is. An integer is a whole number. However, it is a number without a decimal point. So be careful about that. It can be positive or negative. But understand that computers will handle integers a bit different than you would expect, and we'll talk more about that in another video as well. For right now, understand that 7 is an integer here, but 7.0 is not. Good thing to note, if it has a decimal point, it is not an integer. So think of it that way. Let's go back to our program. We're back to our program. Now, I can have multiple variables, because right now I don't want to just hold birth year, but I also want to hold current year and age. Now, you'll notice on this line, I did something just slightly different. I actually declared two variables, current year and age. Each one then is an integer, but you'll notice that I put them on the same line. I separated them with a comma. So I could have put all three of them on one line. That would have been sufficient as well. I could put all three on separate lines. I just did it this way, kind of just to show you could do two different ways. You'll notice, though, in both instances, I'm ending it with a semicolon. Okay, so now we have three integer variables. So the next thing that we need to do is we need to ask a question. So we're going to use our output, which is our printf. And do you remember with our print function, we had a string. And in that string, I'm going to say, enter your birth year. Now notice I didn't run birth and year together because I don't want the user to see this. I just want to see enter your birth year. So that's great. That asks a question. But when you walk up to somebody, you don't just ask a question and then walk away. You wait for an answer. And that's where we're going to introduce the scanf. So the scanf is also a function. So I'm going to show it to you like this real quick. It's also a function, but it works to go get input from standard input. In this case, standard input is the keyboard. So it's going to say, okay, I'm going to go to the keyboard, and whatever the user is typing in, I'm going to look for two things. So we need to talk a little bit about the scanf before we go any further. Okay, so the scanf, I always say, is like an angry neighbor. You know, kind of person where you just don't want to make him angry. So, and the reason I say that is because he will cause you all kinds of problems. So we're going to be nice to him. And the trick with this is to only give the scanf what he wants, and exactly what he wants. So what does the scanf want? There are two things. The first thing he wants is a data type. The second thing he wants is an address. So we have a data type and an address. So you'll notice in this particular scanf that I have on the screen, it says scanf, and then there's a parenthesis followed by a string in double quotes and a %d. The %d represents a decimal integer data type. So when we use the %d, we're telling the scanf to go grab that as an integer. Then you'll notice the ampersand, which in this case is the address operator. It reads the address of. So in order to understand a little bit about this, we have to understand variables in memory. So let's talk about variables in memory. Each time you declare a variable, the computer does find an unused, and it's called unallocated spot, and it allocates memory. Each memory location has an address. Now understand this is a very simplistic form, but I just want you to kind of understand what's going on at this point. So the computer will use those addresses, and you will too, to access values that a variable holds. When a scanf is given the address of a variable, it goes to that address and puts in whatever data type you tell it to. So for example, if we have int age, we have just now put the code in to declare a variable called age that will hold an integer. So what happens is then the computer on this declaration will go ahead and find room. So we have, notice I have my addresses A1, A2, A3, and A4, and it's going to go ahead and allocate spot for age. So now we're going to have the scanf. Let's take a look at this scanf here. We have in red, remember the first thing it needed, an integer. It says, okay, go to the keyboard and grab an integer, whatever the integer you get from the user, and we're going to then tell it where to go. Notice the ampersand. We're going to go ahead and tell it to put the address at location A1. In other words, the address of age. If we look at age in our memory, the address of age is A1. So what happens if I plug in a 22? Say I do a 22 and hit enter. It's going to put 22 into my variable location. So let's go back to our program. So in this case, we have to tell it two things. Remember, we're going to tell it the data type, and then we're going to tell it the address of, hope you guessed it, birth year. So we ask a question, wait for an answer. This together is known as a prompt. We're prompting or asking the user a question, and then the Scanf waits for an answer. So we're going to go ahead and do the exact same thing, asking for the current year. I love copy and paste, so I'm going to go ahead and do that. But be careful if you use copy and paste that you're changing things correctly. So instead of enter your birth year, I'm going to say enter the current year. And instead of birth year here, I'm going to say current year, both of which are integers. So now this is our program, allowing us to ask two questions. At this point, I think what I'd like to do is I'd like to save it, compile, and run it. So when we run it, I'll show you over here, it's going to say enter your birth year. So if you were born in 2000, it'll then ask for the current year, and it is 2020. Then it's done. Now it's only doing what we told it to do. So now we can move on to the next steps. The next thing that we have to do is to calculate. So this would become our process. We have our inputs. In this case, we have two inputs here. Now we have our process. And in the process, we're going to do a math calculation. We're going to calculate what age is, and we're going to take the current year, and we're going to minus the birth year. So if we take the current year, we subtract the birth year, we're going to get age. So this line brings up something else. See this little guy here? What do you think that is? If you say it's the equal sign, think again. This is known as the assignment operator. Please don't think equals. I'll explain that later. But the assignment operator assigns a value to a variable. Please note that it will assign from the right to the left. Therefore, we have something called an L value or an R value. L value stands for the left value. R value stands for the right value. There's a couple of rules that we have regarding our L values and R values. The L value can only be a single variable. One single variable. However, the R value can be just about anything. So in this case, it can also be a numeric literal. Notice I'm assigning 22 to age. It can also be an equation. What if I had subtotal plus tax? Then that value together would be my total. It can be the value of another variable. So this would take whatever my number is and assign it to your number. Also, it can do what we call a function call, and a function returns a value. But we'll talk more about functions later, so don't worry about it. I just kind of am showing you that the L values on all four of these examples are actually a single variable. Age, total, your number, and answer. So be very careful about that. Don't put anything else other than a single variable on the left side. Otherwise, you're going to get a syntax error. Let's continue. We're back to our program. We look and we have our age calculated. Notice our L value is age, a single variable. We have a calculation to the right. So the last thing that we want to do is we want to be able to run this and produce output. So that's our last step. So this time we're going to do a printf to produce. You will be, let's just say, 22 years old in 2020. Now bear with me here. If I have this right here, what do you think is going to display on the screen? I'm probably going to see you will be 22 years old in 2020. So no matter what I put in for birth year, no matter what I put in for current year, it's going to tell me this number here and 2020. But let's get that to run because I want to show you something. So let's use dates that we know for sure aren't 22 years old. So I'm going to go ahead and run it. And I'm going to say my birth year was 1990. And I'm going to say the current year is 2020. So is that true? I'll be 22 years old in 2020? I wish. However, even if you were born in 1990 and you're at 2020, you're still not going to be 22 years old. But I did this for a reason, because I want you to see where the 22 shows up and where the 2020 shows up. So what happens is this 22 is actually should be age, right? So we want an integer to show up here. So in this case, we're going to use a %d, because remember, %d was a digit, a decimal integer. And here we want the current year to show up. great, this would work in 2020, but it might not work in 2021 or 1999 for that matter. So the current year, we want another integer to show up here. So you'll notice I have 2%Ds. If I do this, then I have to tell it which variable integer to show up here and which variable integer to show up here. Order matters. So what I'm going to do is I'm going to separate them with a comma. So make sure you put a comma first. Please note the comma is not inside the quotes. Okay, so we're going to do a comma here, and then we're going to tell it age, and we're going to tell it current year. Now, one thing that I want to point out, did you notice I did not use the ampersands? I don't want the addresses to show up. I want the actual values. I want the number to show up here, and I want the number to show up here. So we do not use ampersands in our printf. Okay, so I'm going to go ahead and save it, compile it, and run it. So this time I'm going to run it, and I'm going to say the birth year, let's go do our 1990 again, and the current year is 2020. So this year you will be 30 years old, and that's exactly what it says. We're going to run it again for another age. So I'm going to go ahead, and this time I'll choose birth year is 2000, current year is 2020, so you will be 20 years old. So you'll see we were able to do inputs right here, a process, and an output using a printf. So this is your program that will do input, process, output. And we were able to talk about the assignment operators. We were talking about the Scanf a little bit, and declaring integer variables. Okay, I hope this helps you on your assignments. I'll talk to you soon.